Guys, this particular video will be addressing a couple of things, and um, in the previous video we talked about what the whole plan is, what the channel is going to be about, and basically what we're going to be doing. So this is the playlist. This is a video that's going to be part of the deep learning playlist where we get to build deep neural networks from scratch, implement papers, research papers, and basically build a framework at the end, kind of like PyTorch or TensorFlow. So this video is going to be answering a couple of questions, which is what is deep learning? I'm pretty sure already know what ML is. So we're going to be answering questions like what is deep learning, what is a neuron. In the future we'll answer questions like what neural networks are, but now what is a neuron, what basically is learning, and what is gradient descent. So let's jump right into it. So what is deep learning? I'm super sure already know what machine learning is, and deep learning is just basically a field in machine learning where we have neural networks. Basically, that's just all deep learning is. It's just about neural networks and deep neural networks, and of course it's not just one specific type of neural network. There are so many types of neural networks, so many architectures. Neural networks can be really defined by the type of activation functions that they use. Some neural networks are more complex than others. Some are deeper than others, just stuff like that. So, okay, for example, you could do your own home research on this. We'll go detail into it later. We are most likely going to be coding a lot of these architectures from scratch. So an example is a recurrent neural network. It has its own characteristics. It has its problem that it solves. It has where it thrives and where it fails. We have convolutional neural networks. We have generative adversarial networks. So we have so many types of networks. So all these networks, all these algorithms, anything that has to do with networks, neural networks, it's all under deep learning. And deep learning is still machine learning, but we are precisely talking about neural networks. So then what's machine learning? Machine learning, we're talking about something that's way more broad. So an ML algorithm doesn't have to be a neural network. It can be a random forest algorithm. Again, you can do your research on this. It can be a regression algorithm. We have simple regression, we have lasso regression. It can be an XGBoost algorithm. It can be a stacked algorithm, a stacked regression algorithm. It can be, there are just so many algorithms under machine learning, but then deep learning focuses on neural networks. So we have answered that question. So that is out of the way. So what are neural networks? Neural networks are big. They're basically a combination of neurons connected together. Neurons can be fully connected, which are dense. We call them dense, well, not dense networks, but then dense layers. I'll get to what layers are and all that. So, okay, in order not to complicate things, let's leave neural networks alone and let's go into what neurons are. So neurons are just basically a tiny part of neural networks. So, okay, let's go on Google and let's get an image. So just like you have cells. Cells are small, right? But then inside cells you have other parts and components that make up a cell. So let's look at the whole cell as the neural network, and let's look at these small parts that make up this cell as a neuron. So let's yeah, cool. So if you look at this image right now, this is basically a neural network. And these points here, these are all neurons. So many neurons make a neural network, basically. So What are neurons? So let's go back to something on biology. How does the human body or the human brain work, or how do we take actions? How do we think? How do we respond to stimuli? It's all going to boil down to neurons and neurons firing actions. So let's say somebody pours hot water on your hand, and we all know the reaction to that is going to be ouch, or oh, you just suddenly move your hand. If you are leaning on a wall or you touch a door handle that's really hot, why do you just immediately just throw your hand off it? It's just a basic protection for your body so you don't get burnt. So what controls that action? A lot of times you're not even in control. A lot of times you touch a hot doorknob and you just fling your hand somewhere and you just end up throwing the phone you were holding, or hitting someone, or breaking a laptop that you were holding with your other hand. So why? Because obviously you don't want to break your laptop. So why this involuntary action? So basically what happens is when you touch a hot doorknob, uh, your body can obviously read temperature and you have nerves. So these nerves fire a particular signal, set of electronic signals. Well, I'm not really a biologist, but then I think there's some chemistry involved, but it all boils down to positive and negative electrons and electrolytes and stuff like that. So it sends this signal to your brain, and then your brain interprets the signal. And after interpreting the signal, your brain passes in some resolved actions to another set of nerves, and those nerves act. And in this case, that nerve will be your hand, and the action will be you removing your hand very quickly from the doorknob after you get burnt. So, um, so now, how does this affect neural networks, and how does this affect AI and deep learning and stuff we're doing? Basically, a neuron is just like a gate switch or a decision maker. It just basically takes in a set of inputs and it does some calculation and deliberation, and then it brings out some outputs. So when your hand touches the doorknob and signals are sent to your brain now decides what to do. Okay, is this cold? Is this a signal of a cold surface? What's this signal trying to say? After understanding this information, interpreting this information, then it makes a decision and sends results. Basically, neurons are just decision makers. So let's make it more visual, because if you haven't done anything on biology, or you haven't done anything on this before, you will probably get lost. So this is what a neuron basically looks like. It's not like we're going to write some code and make some circular stuff. No, but all this here is just basically representation. This is just architecture. If you have done stuff on software architecture before, like we would usually draw out a diagram. Okay, let's say you're creating an API. You usually draw a cloud that represents the service online, and then you have something that represents the database, and you have something that represents the mobile phone, and you have something that represents the server, and you have something that represents the web client, and you have something that represents something, just a lot of other things like that. And then you have lines that connect and show how data flows. So all that drawing, all the architecture, that is just what we're trying to do here. So that's why you have lines and all that. This just shows flow of information and stuff like that. So we're not really going to be coding. You get round stuff and whatnot. It's just basically representation. This is basically pure architecture. So let's see what we're trying to do. We're trying to represent a neural network. So a neuron is basically a decision maker. So we have a neuron here. Let's just make it round. And let's go back to the example I gave on you touching the hot doorknob. So we have data coming in, data coming in, data coming in, and then we have data going out. and then this data going out, you have a nerve here, and that nerve connects to a tissue, and that tissue connects to other tissues, and it so happens that these other tissues are connected to your hand, which makes you just scream, ow. Okay, it's not even just connected to your hand, it's also connected to your mouth and your emotions, and maybe your heartbeat start racing, stuff like that. So it's connected to a whole lot of layers. And it's okay, in the real situation in your brain, it's not just one neuron actually. So this is just me being this is just for explanation purposes. There are billions of neurons in your brain and they all make decisions. And that's why you touch a doorknob and you shout ow and you jump up. So let's say that this what's coming in here is temperature, let's say 20 let's say 20 degrees. And let's say what's coming in here is maybe some stuff on vision from your eyes. And let's say what's coming in here is stuff on the texture of the surface that your hand touched. Or maybe some other set of data. And then all this data come in here. And here, a decision is made. Is it hot? Is it cold? What's the action to take? In the real sense, one neuron will not make all that decision in the real life sense in your brain. There are going to be billions of neurons that are going to pass data to this and pass data to this, and they'll all finally come to a conclusion. But for the sake of representation, we're just using one. So let's say all the argument goes in here, just like a courtroom, and they all argue, oh, it's hot, the temperature is hot, it's painful to the skin. What action should we take? Should we make him scream Jesus? Should we make him scream yeah or ouch or fuck? Okay, I'm not supposed to, damn, I'm not supposed to, sorry. Okay. So he just basically makes a decision. And then the decision gets fired and an action takes place. So that's all biological. This is not a biology class, and I don't know so much about biology, but I know a little bit. So that's that for that. That's why it's because the architecture is designed in this way. That's why it's called neural networks. And the inspiration for this whole concept and architecture is based on how the brain works and how neurons work in the brain. So, and I've said this before, but I should say it again. There are other types of architecture and algorithms and architectures in machine learning, but this is deep learning. We are talking about neural networks. Now, let's make this more mathematical, and let's bring this back to computers. Let's say we're building an AI application that determines whether a user, okay, let's say we're building a recommendation system and we're trying to determine whether a user would like this particular video. Let's say this is where the guy is building stuff for Netflix and and you know when you're watching Netflix, when you open Netflix, you have lots of movies. There are billions of hundreds of thousands of movies on Netflix database. How do they decide what to display to you at what time? Now, how we're going to solve that is we're going to take in some data. Let's say the data we take in, let's just say this is this data. And let's say this data represents the time of the day. Let's say this data represents your age. And let's say this data represents all the movies you have watched in the past. All these data are taken as input, and then some processing is done, and then we output a binary, either 0 or 1. 0 for no, you will not like this movie, 1 for yes, you like this movie. So by the time we run 100 movies through this algorithm, let's say 20, the algorithm says 20 of these movies you would like. That 20 gets displayed to you by Netflix. So I hope I've been able to give some overview on how neural networks work, basically. So I know it still sounds confusing if you haven't done anything on this before, but this is just basically laying out the ground concept, because we can't understand how neural networks work without understanding how a single neuron works. And remember that a neural network is just basically a combination of neurons that are connected whether fully or partly. Now, so coming back to this neural network architecture we have here, you can see that we have this set of neurons, we have another set of neurons, we have another set of neurons, we have another set of neurons. Like I said, before we were just using one neuron. Well, I told you earlier that in a real life situation in your brain, you would have like billions and millions of neurons. So also for a computer, in a real life example, if we're trying to do something on Netflix, we'll have millions of neurons. So now, let's look at all these neurons these ones here. These are the first set of neurons, and by convention we call them the input layer. So basically, once you see a set of neurons lined up like this, we just call it a layer. So we have layers. So here you can see input layer. Oh, Google has done a good job. Input layer, we have an hidden layer, we have another hidden layer, and we have an output layer. So any layer that's not the input layer or the output layer, we call it a hidden layer, because they are like kind of like in between. They are hidden, like they're not like exposed. So we have input layers here. Okay, let's say we're feeding in an image of, this might be complex, but let's say we are trying to classify an image, whether there's a dog or a cat in an image. We could feed let's say the image was 28 by 28 pixels. We could feed the image, we could feed that data into the neural network as an input layer. But we're not going to fit in 28 by 28 pixel data like look at, this is 1, 2, 3, this is 3. And if we're going to feed an image into this network, there's going to be a 3, well, not even a 3 pixel, image, because we can't really feed in an image that's 3 by 3 pixel into this network. We have to flatten that image. Yeah, I don't really know. Okay, I don't really know how to break that down, but in the future, I'm trying not to say so much. In the future, we'll get into all that. So let's go back to neurons. Now, I've explained the architecture of neurons to you, and I could put some resources in the description, in the link, in the description below, links to resources and stuff that you can read to get you started on neurons. So let's dive into some code. Let's go into some code. In this code, we're going to implement different kinds of neurons. Again, if you're not really grabbing the whole concept of deep learning already, don't worry. You're not going to grab the whole concept of deep learning in just one video. Besides, I've not gone into a lot about deep learning. We're just talking about neural networks here. We're just talking about neurons. We have not even started talking about the whole neural network architecture yet. So we're still on neurons. So slow down. So let's draw an architecture of a neuron to start with. Let's draw a neuron. Let's create a neuron that takes in 3 input data points and outputs 3 input data points. It's a simple neural network. Taking this, outputs this. Cool. So, yeah, let me go back on this. Go back on this. Go back on this. Go back on this. Yeah. So ignore all this down. So let's use this. So again, if you don't know what this is, I'm not using a code editor and a Python runtime environment locally. This is Colab. It's a notebook. If you don't know what notebooks are, you might want to search on that. I could do another video on Jupyter notebooks and Colab and how to use them, how to set Python up on Jupyter notebook and Colab. It's super easy. So now so the point of this is when I run this code, it's not running on my system, it's running on Google server. So a request gets sent, the code gets chunked, and I mean, the code gets sent to the server and then it's run on their system and then the result gets sent back. So this is good in a situation whereby you are using a PC that probably has like a 2 gig RAM and when you're doing anything on machine learning, you really want to have a fast system, a system with most advisably you should have a system with a good GPU and at least 8 gig of RAM, but that's not even good. You should have 16 gig of RAM. That would be cool. And then you should have a GPU. And if you're using a Mac and don't have a GPU, you could have an external GPU. So when we are doing more complex stuff, I will start to talk about GPUs and all that, and training on GPUs and training on code. But later I might do a video on Jupyter Notebook and stuff like that. But for now, just go to collab.research.google.com or just go to your Google Drive. Okay, yeah, you can go to your Google Drive and then you can just simply click this add button and then go to more and then click collab, Google Collaboratory. So you just instantly get this. So I'll do a video on how to use this later. But for now, if you know how to use Python, I mentioned Python as a prerequisite for this playlist or this course. So if you know how to use Python, you can always just run this code locally, like you always do on your system. So what we're trying to do in this code, what we're doing here is simply just implementing what we did here, what we have drawn out here. This is our architecture for this. It's a simple neuron, and yeah, this is what we're doing. So first of all, we're importing NumPy. NumPy is very useful and essential in the ML and data science space. What NumPy does for you basically just gives you a set of functions, a lot of functions that help you manipulate data in formats like float formats, integers, arrays, different kinds of data types. So it just allows you to do all that manipulation. See how I'm creating an array by just writing np.array here, and then it allows you to do stuff on matrix multiplication. Later we'll talk about I will touch metrics and vectors in this video. So we have imported NumPy as NP. Again, you should know how to use Python if you are going to follow up on this course. We are defining weights, and we're basically defining weights as an array. And here we're creating a function that basically takes an input and weights, and then we return an output, which is the prediction. So let's come back here. Like I said, when we're talking about Netflix and recommendation systems, let's say we are taking in the time of the day here, and maybe whether it's Christmas or not, or if it's a festive season, basically data on time here. We're taking in data about you here, and we're taking in data, let's say your age and stuff here, and we're taking in data on your past movies that you have watched here. When we come back here to our code, all that's the input. When we finally make a prediction on whether this movie is good or not, and that prediction is either 1 or 0, this output here, 1 or 0, that's it here. We're returning it here. Now, when we bring in all this input, how do we just come up with an output? What magic goes on in here? Well, the simple magic that goes on in here is the magic of dot product. Simple. Dot product, which is not really multiplication. It's kind of like multiplication, but it's a little more complex. It has to do with matrices and vectors. So, this line we have here basically shows relationship between this input and this output. And what we're going to have here is basically weights. We could have a weight here, we could have another weight here, we could have another weight here. So how do I explain what these weights are? Weights are basically just like the name denotes, weights. They determine how heavy, or in this case, how important a particular feature is. Now, if I'm trying to make a decision whether a movie is good for a user as 1 or 0, there are some things that are going to be really important to making that decision, and there are some things that are going to be less important to making that decision. For example, the time of the year or the day or the season is super important. Your age is important, but not as important as the season. And it depends. It depends actually on the data you have. Because all this will not even determine it. We are not the ones that are going to determine it at the end of the day. All the weights are going to be determined automatically. That's why it's called learning. We're not hard coding it. And like I said before, learning is just basically it's just basically this equation, y equals to mx plus b. Okay, sorry, this is not clear. Just visualize it. Y equals to mx plus b. We all know that equation from math in high school or further math or university. When we are learning, we are just basically trying to find the best m and the best b that makes a given input x equal to a certain output y. Simple. So, like I said, your age and you are not really so important in determining whether you like a movie or not. And what's the last feature that we have here? I think it was past movies that you watched. Now, past movies that you watched is very important, and it's even more important than the day or time or season of the year. Now, all these weights, all this level of importance of these features all determine the output. Just like you have the equation y equals to mx plus b. Let's do a little experiment. Let me create a new cell. So in Colab, this is called a cell, this is a cell, this is a cell, this is a cell. Let's create a new cell. And let's do our y equals to mx plus b equation. Let's say that y, we don't know y, so we're trying to find y. Y equals to, let's say our m is 4, our b is 9, and x is 2, and y equals to mx plus b. So let's run this code. Yeah, let's print y. Yes, so y is 17. Wow, that's awesome. Y is 17. And this is basically very simple, right? And I'll show you how this relates to this. Y equals to mx plus b. Our m is 4, our b is 9, our x is 2. Now, let's say that, because we're trying to do machine learning here, so we're trying to learn. We're trying to make this program learn. Let's say our real y, let's call it ry. Our real y is, let's say our real y is 20. And according to this equation, with these parameters, with this m and this b, our y is what? 17, which is wrong. Y is 17, that is wrong. Our real y is supposed to be 20. We want 20. In our training data set, real y is 20. How do we make this algorithm? How do we make this equation? How do we make it learn? We don't want to come here and start to add code and start to find what parameters. Basically, ML is just you saying, our real y is 20, right? what can we do to make this 17 20? You know what? Let's increase what m is. Let's take m to 5 and let's see what we have. Oh, 19, close to 20, close to 20. So how can we make this 20? Let's do something. Let's make b. Let's add 1 to b. Let's plus 1b. Dope. Now we have 20. So now, before our equation was m is 4. That is 4 times x plus 9. Now our equation is 5 times x plus 10. You see how we have changed our equation by updating m and b? That's basically what ML was all about. And that's basically what this m and b, those are basically weights. Y, this is our y, the output, equals to m, your weights, x, all your inputs, plus b, your bias. Simple. So I'll get to what b is in a minute. Maybe not in this video. I'll attend to what b is. Well, I shouldn't really have started with mx plus b. I should have just, most courses or books you read, when they're starting out, they'll take out the b. But I decided to add the b because so that you'll be able to recognize it. So once you see mx plus b, you're like, oh yeah, I remember this linear equation back in high school or something. That's why I put the whole full linear equation mx plus b so that you just recognize it instantly. So you see how we have been able to tweak our way to make this 20. Well, we did that manually, right? We did that by changing the code with our hands. But you can't be doing this for millions and billions of data sets, and even each data set we have millions of input features, like 100, 1,000 input features. So the process of writing an algorithm that will automatically do this, automatically adjust m and b, is machine learning. So let's go back to deep learning, neural networks, neurons. So we have our weights. Now you understand what weights are. And let's go back here to remember our architecture. We're taking a set of inputs and we want to get one output. That's our architecture. So here we can see that we're doing some multiplication. Input times the weight. Remember here that our input was x, the weight was m, and our bias was b. Here we're not using any bias. Yeah, let's not use any bias for now, so I didn't get so confused and like you start wondering why are we using bias. Let's just leave the bias out. And so you may say, okay, why are we not doing something like input times weights? Well, that's not bad, but then we're trying to find the dot products. This is matrices and vectors. We are not doing 2 times 2. We are doing something like this that probably has a shape of this. We are dealing with, in real life, we're going to be dealing with data like this. You're going to be dealing with different kind of arrays and matrices. So I'll get to what arrays and matrices are in a bit. So that's why we're basically using the dot product. And notice that this input, where this dot is coming from is here we're using NP array. So I told you that NumPy comes with a set of functions that help us do some things really quickly. If we're going to write this dot function from scratch, it's going to take a lot. So basically our dot is just simply multiplication, but it's a more complex form of multiplication because we're not dealing with simple numbers like integers or float data type. We are dealing with matrices and arrays and vectors. So matrices and vectors. That's why we are using dot. So we are still basically doing the same thing, mx plus b. So now we don't have b, so let's just say mx. So our prediction is basically the input multiplied by the weights. Same thing here, our y. And now we're returning this y as prediction, and we're returning this. This is basically this right here. This, as simple as it is, this is basically a neuron. Super easy. But it gets more complex later. it gets more crazy later. There gets to be more calculus later. So now just rest lines of code. What are we doing here? What are we doing with all this? So all these, they're just data. We're just trying to create data. So we're just creating an array that has this, that has this, that has this. Basically, what we're trying to do is that we're trying to have 3 data sets. No, not 3 data sets. That's data sets are much larger. We're trying to have 3 data points. Should I call it data points? We're trying to have 3 sets of data basically. So we have a feature, we have another feature, we have another feature. Again, I don't really want to start explaining what features are. I think you should have done ML stuff before you came to deep learning stuff. So I'll just assume you know what features are. So our input data, we're trying to make our input data take this particular feature, just one of its tools, this and this. We can even make it more simple. We can actually make this more simple. You know what? Let's get rid of all this. I was doing something before, that's why you had all those. Let's get rid of all those. Let's get rid of all those. Let's make our inputs. Here, let's come out to our architecture. We can see our inputs is this is 1, 2, 3. We have 3 input features. So let's have 3 features here. Let's have 2.0. Let's have 5.0. Let's have 2.7. And our prediction, we're going to just run this function, passing the input, which is this, and then the weights, which is this. Cool. And let's run it and see what our prediction will be. Yay, our prediction is 1.2. Awesome. Now, our prediction is 1.2. Remember that our network architecture is supposed to output a single value. So that means we got something right. We did it right. We are correct. We are on the right track. We got 1.2. You might not believe it, but you have just created the simplest form of neural network you can ever create. Congratulations. I know it's not much. I know you're probably sad right now, like, okay, how does this contribute to AI? How I don't get the big picture. Well, you will soon enough. But that's just one type of architecture. Here, notice that this particular neuron is taking in 3 input, taking data from 3 neurons. It's taking data from this neuron. If you watch this closely, this neuron, if you watch this line, you can trace it all the way here. If you watch this line, you can trace it all the way here. If you watch this line, you can trace it all the way here. And each of these lines, they represent weights and connection, basically. Now, it's taking all these 3 input data, this neuron, and it's outputting 3 output data points. You can see this 3 output data points here. So the question is, no, it's not even outputting 3, it's outputting 4. That's awesome. It's outputting 4. So how do we do this? That's the question. Our former architecture took in 3 input data points and brought out 1 output data point. Well, let me just show you how to do that. It's not so hard. Notice that here we have 3 weights as inputs. 3 data points, and we have 3 weights. This line, this line, this line. Sorry. Now, those three weights, these are the weights. 1, 2, 3. These are the weights. If you want to output 3 data points, you will need 3 weights for the 3 other data points. Okay, let me make this more clear. Cool, let me make this more clear. You have your neuron here, 3 inputs, 1, 2, 3. I want to do 3 outputs. 1, 2, 3, so that hopefully another neuron will come in here, and that neuron will come in here, and that neuron will come in here, and they will just, so awesome. Now, these are W1, these are W2, W2, these are W3. This W1, W2, W3, they are here. W1, W2, W3. But then we need another a way for us to, because before we had just one output, and that one output had W1, W2, W3. It has to. And now we want to have 3 outputs. So those 3 outputs need to have W1, W2, W3 for 1, W1, W2, W3 for output 2, W1, W2, W3 for output 3. So in order for us to do that, that's actually very simple. All we simply have to do is create 3 sets of weights, that's all. So we'll just do this, we'll put those in an array, so we'll have 3. And let's just say 0 0.3, 0 0.4, 0 0.5, 0 0.2, 2.8, 4.8. Now, this is W1, W2, W3 for output 1. Remember, we're trying to have 3 outputs. W1, W2, W3 for output 2, W1, W2, W3 for output 3. Cool. And our input is what? Just an input that has X1, X2, and X3. 3 features. So let's run this code and see what it gives us. Awesome. So what it gives us is basically an output. Let's just call the output Y. Y1, Y2, Y3. Remember the first example we ran, we just had an answer of 1.2. But now we're having an answer of this, this, this. So we have successfully created this architecture. Now, being able to create different architectures like this all come together for us to have this, and that's where it gets more complex. And now, okay, so let me say something here. There's a terminology called feed forward, and the terminology called back propagation. In the future, we'll talk about those and read papers on those. Feed forward is just basically movement of data, flow of data from the input neurons, the input layer, not neurons, the input layer to the output layer. That's feed forward. Back propagation is basically movement of data from the output layer to the input layer, so that we can, and why do we want to do that? So that we can, we're not trying to predict backwards, we're just trying to update weights to enhance our learning process. But I'll get to all that in the future. I'm not going to talk about that now. But the key takeaway that I just want you, I'll say a lot of things that are kind of like vague. If you are new to deep learning, you may not really understand, and if you have done stuff in deep learning before, you might get what I'm trying to say. But the main thing is just understand is just this video is just all about neurons, not neural networks. Neurons. We are zooming into neurons, and what we have done here is a neuron. So what I advise you to do is I advise you to write this code by yourself. If you're looking at it on your screen right now, just write it by yourself. It's a simple piece of code. Forget about all this down here. This is for later. Just write this and just play around with it. Play around with it, and while you're playing around with it, visualize this. Draw this out with a pen and paper. Visualize it. Understand what's going on here. Understand that we're having x1, which is an input, x2, x3. Like I gave the Netflix example before. These are features that we can use to make predictions. And these are weights. Weights just tell us how important these features are. And by tweaking these weights, we can get a desired output. And why are we just trying to do that? That doesn't really make sense, right? But we are doing that because y equals mx plus b is an equation that allows us to understand relationship between two variables, which is x and y. And M and B's are parameters. And all a machine learning algorithm does, whether neural networks, whether random forest, whether linear regression, all the ML algorithm does is find the right M and the right B. So you might say, oh, how does this come into play when you're dealing with large data like image data? Well, all your image data is just basically a set of arrays. All your audio data is a set of arrays. Any kind of data in this world is just going to boil down to numbers, zeros or ones, or a set of numbers. And those set of numbers can be used to represent M, X plus B. That's all. So later in the next video we'll be talking about gradient descent. And gradient descent is basically an algorithm that allows the model to learn. So what we're doing right here right now is just prediction. And you can see that we're hard coding our weights and our inputs and all that. But when we are using gradient descent, it will now automate the process and allow the software learn what M and B is supposed to be so that it can derive Y from mx plus b. So don't forget that equation, mx plus b. That's the basic principle of everything that is done in machine learning. So I'm really tired. Thanks for learning. Thanks for watching this video and learning with me. So if you have criticisms or stuff you want to say, just leave a comment below and I would read the comments and give you a reply. If I can't reply you in comments, I would mention your question and the answer to your question in the next video.